Welcome to The Explainer. Today, we're diving into a threat that is, well, it's totally invisible. It doesn't have the sudden, dramatic explosion of an earthquake or the terrifying, towering waves of a tsunami. But make no mistake, this slow-moving disaster silently wipes out crops, wrecks entire economies, and shatters lives. It just sort of creeps up on you, one dry, sunny day at a time, until suddenly the landscape is literally unrecognizable. And the human toll of this quiet progression, it is absolutely staggering. Just to put this into perspective, between 1970 and 2019, these dry spells contributed to over 650,000 deaths worldwide. Plus, we're talking hundreds of billions of dollars in economic losses. There's a really good reason experts often call this the slow onset disaster. So, all this naturally leads us to a pretty massive question. How does simply missing out on rain become one of the world's most devastating natural disasters? Like, how does skipping just a few months of precipitation trigger this unstoppable chain reaction that leads to famine, mass migration, and even major political instability?
Well, let's break it down, starting with what this silent disaster actually is. Okay, so here's the crucial thing. A drought is not just a heat wave. It's actually a prolonged period of unusually low rainfall that creates this massive, severe imbalance between water supply and water demand. It's kind of like your bank account, right? A drought happens when the withdrawals from our water supply, stuff like evaporation, plant uptake, and human consumption, just consistently outpace the deposits we get from rainfall. You're basically overdrawing your account. And once that account is overdrawn, a relentless domino effect kicks in. It starts out simply enough, right? Just below normal rainfall. But then soil moisture drops. Since the plants are suddenly thirsty, agricultural production takes a huge hit. After that, the rivers and lakes start to shrink, which creates these widespread water shortages that lead directly to spiking food prices and ultimately massive economic stress.
So, what exactly is causing this? Let's look at the anatomy of a drought and its natural and human causes.
The origins are actually a really complex mix. On one hand, you have natural atmospheric anomalies. Think of persistent high-pressure systems that literally act like an invisible wall blocking rain clouds. Or massive ocean currents like El Niño, shifting weather patterns across the whole globe. But humanity plays a huge role here too. Things like excessive groundwater extraction, sweeping deforestation, and of course, climate change, fundamentally altering these global patterns, making the whole situation much, much worse. Droughts also evolve through these distinct compounding stages. It almost always kicks off as a meteorological drought, which is just a pure lack of rain. But if that persists, it morphs into an agricultural drought as the soil dries out and crops start failing. From there, it deepens into a hydrological drought. That's when rivers and underground aquifers physically shrink. And ultimately, if it keeps going, it hits the socioeconomic and ecological stages, completely disrupting energy supplies and sparking those devastating wildfires we see on the news.
Let's zoom out for a second and look at global water crises from a historical perspective. Because the scary truth is, absolutely no region on Earth is immune to this. Take the US Dust Bowl in the 1930s. That was caused by a brutal combination of drought and some really poor land management. Fast forward to 2011, and repeated rainfall failures in the Horn of Africa devastated millions. In 2018, the major modern city of Cape Town nearly hit day zero, a point where municipal water was projected to just run completely dry. And in 2022, we saw modern European rivers drop to historic lows, which completely crippled hydropower and river navigation. If we zoom in on India, for example, which is a country that relies incredibly heavily on the seasonal southwest monsoon, we can spot some very specific high-risk regions. Places like Rajasthan, Maharashtra, and Bundelkhand are repeatedly facing severe risks of both massive crop losses and critical drinking water shortages. And this vulnerability, it's only being supercharged by rising temperatures, population growth, and the rapid, somewhat alarming, depletion of their underground groundwater reserves. Now, let's shift gears and look at the economic ripple effect of all this. From an economic and investor perspective, prolonged droughts just completely scramble global supply chains. Obviously, industries like agriculture, hydropower, and beverage production take a tremendous hit. But here's where it gets interesting. This massive stress simultaneously drives immense demand for solutions. Industries focused on large-scale water treatment, seawater desalination, smart irrigation tech, and even developers of drought-resistant seeds, they are actually seeing significant growth as society races to adapt to these dry spells. Now, it is absolutely critical we separate myth from fact right here. A drought and a famine,
They are not the same thing. A drought is a severe shortage of water, whereas a famine is an extreme shortage of food. It's a subtle but huge difference. While a drought can certainly contribute to a famine, things like effective government intervention, forward-thinking global trade, and smart water management can absolutely stop a dry spell from turning into a starvation crisis. Which brings us to exactly how we are engineering tomorrow's water.
Because human ingenuity is fighting back big time. Today, scientists and engineers are rolling out some incredibly advanced technologies to essentially see droughts coming before the ground even starts to crack. We're talking about artificial intelligence powering seasonal forecasts, constellations of Earth observation satellites, and IoT sensors feeding real-time data into exact digital twins of our watersheds. By mapping all these trends, we can actually monitor water availability months in advance. How cool is that?
And down on the ground, massive infrastructure projects are actively building up our resilience. Coastal regions are pouring money into desalination plants to literally turn seawater into fresh, drinkable water. Inland, we're seeing expansive wastewater recycling programs and the massive adoption of smart, sensor-driven drip irrigation. Even ancient historical methods like rainwater harvesting are getting a modern upgrade to completely optimize how we manage our reservoirs.
So as we look toward the future, I really want you to remember the single vital number, less than 1%. See, although water covers a massive 71% of Earth's surface, the vast majority of it is saltwater, or it's permanently locked away in ice. Less than 1% of all the water on Earth is actually readily accessible fresh water sitting in our rivers, our lakes, and our shallow groundwater.
Just think about that. That tiny fraction of a percent supports billions of human beings, global agriculture, entire ecosystems, and all of modern industry. But if we treat that shrinking bank account carefully, through smart engineering, proactive conservation, and a really deep understanding of our water cycle, we can absolutely secure it for future generations.
Because the ultimate question isn't whether the rains will stop again. History pretty much guarantees us they will. The real question is, will our infrastructure and our policies be ready when the well runs dry? Thanks for joining me on this explainer, and as always, keep questioning the world around you.